Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're going to look at paper 2 revision, which has these 4 important topics. Now, the first topic that I'm going to look at is the analytical geometry. So the analytical geometry has got 25 plus minus 25 marks. That is 25 plus 3, plus minus 3. The next topic that I'm going to look at is the trigonometry, which has got a lot of marks. And it's an easier question. We can simply get up to 30 marks in this question. When we do the activities, I'll show you how we're going to get it. The next one is the Euclidean geometry, which is plus minus 40 marks. Then out of the 40 marks, we can get up to 20 marks. And I'm going to show you how also. CAAM is the circles, angles, and angular movement, plus the measurement. It's 35 marks, plus minus 35 marks. And if you calculate all these marks, the 50 plus 40, it's 90, plus 25 plus 35, that gives us a total of 150. So our paper 2, it is out of 150 marks. Right. Now, very important. What we're going to look at now is the information sheet. This is what we call the formula sheet. We call it the information sheet. Now, when you were writing your paper 2, please identify the formula that we're going to be using in paper 2. So here what I've done is I've gone to the formula sheet, and I hope and trust you have your formula sheet in front of you so that we identify the formula that we're going to be using, mostly used in paper 2. In analytical geometry, these are the formula that we're going to be using. These are basic formulas that we're going to be using. Know that that formula, that first formula there that I have there, that I'm highlighting now, is the distance formula. In other words, if you find that the question is looking for the length, or the distance between the 2 points, or a point where the distance is given, then you must use that formula. The next formula is the midpoint formula, whereby you'll be asked calculate the coordinates of the midpoint. So in other words, of a line. So in other words, the 2 points will be given. You will be requested to calculate the midpoint. So it's a point, it's an x value and a y value. The gradient formula, the next one is the gradient formula, which is y2 minus y1 over x2 minus x1. Please check the formula and copy it correctly into your answer book, because we see that a lot of mistakes that you do there, where you say x2 minus x1 over y2 minus y1, and the formula sheet is there. So please copy it correctly, and you'll get a mark for that. Inclination angle, in other words, we're talking about the angle that is formed between the x-axis and the y and the line and the straight line. So that formula there, it's also for that. So the m is for the gradient. So in other words, if my gradient is not given, then I must first get the gradient. After getting the gradient, then the tangent of it, I can then get the angle using the tangent. Please, we only use the tangent for now. Okay, the last one is the ellipse. So in other words, that formula there, it's for the ellipse. So that's where you'll be given a question like that and say, draw the graph of an ellipse where you have the x squared over a squared. The a will be given, or the a squared will be given, and the b squared will be given, or b will be given, okay, with a square. All right, hope now you understand that when you're doing your analytical geometry, this is where you go, and this is the formula that are going to be used And you're going to also use the formula whereby you have your equation of the straight line, which is y minus y1 equals to m into x minus x1. That formula also, I can use that formula there to get the equation of a straight line. So the equation of the straight line, that formula can be used there. Right. Now in trigonometry, so now, for instance, I'm now practicing my trigonometry, which is my favorite topic. Trigonometry. Now I'm practicing that. Where do I go? I go to this formula. These are the formula that I know I'm going to be using. These are the formula for the sine rule. Remember the sine rule, the formula that I'm either going to use those two, or I'm going to use those two, or I can use this one and that one. So I cannot use the whole formula as it is. So I must check what is given, then from there I use the correct formula. The next one is the cosine rule. Remember, they'll give it to you like that. There was a question in one of the papers whereby you're requested to only complete that part. In other words, you're given that, you are only complete that part. And that part is there in the formula sheet. So you just go there and check which lines have been given and indicate the B with the line that is given, the C with the line that is given, and the A with the angle that is being given. Right. The area rule, so it's there. When do I use the area rule? I use it when I'm asked to calculate the area of a figure which does not have a 90-degree angle. Okay, so that is the formula. So I'm going to use the two sides and the given angle. Okay, right. The identity is very important. Please note this identity here. It's an angle here. There must be an angle there. So it's the sine squared of theta plus cos squared of theta equals to 1. That identity, they ask it a lot, so you must know it. The second one is 1 plus tan squared theta equals to sec squared of theta. And the other one is cot squared of theta plus 1 equals to cosec squared of theta. Right, these are the ones that are going to use. Remember, there are questions whereby there's what we call integration, where you find that you have to go and calculate something using another formula, which is not a trigonometry formula, but using another formula, then from there coming back to your trigonometry. So those questions, we call them the integrated question, whereby they integrate the topics like trigonometry, they integrate it with analytical geometry or calculus. So now, the next one is the circles, angles, and angular movement. I love this formula because one of the things that I like about this formula is that they tell you this formula is for the angular velocity. In other words, when I go to my question paper, I look at my question paper and they ask there in question 10, somewhere in question 10, they ask calculate the angular velocity. So I just come to my formula and then from there I choose this formula. Remember, it is like that or like this. Okay, remember 2 pi is nothing else but, because it's in radians, so it will be 360 degrees and then multiply by the n. They even tell you that n stands for the rotational frequency. So the question might say calculate the rotational frequency given the angular velocity. So the angular velocity is given, the pi, you know how to calculate it. Then from there you need to calculate the value of n. Same applies to the circumferential velocity, which is v equals to pi. D stands for the diameter. They even tell you there. They even tell you that n stands for a rotational frequency. The next one there, it's S equals to R multiplied by theta. They even tell you R is the radius and theta is the central angle in radians. In other words, if it is given in degrees, then you're going to change that by using that formula in there. So we're going to change that from radians to degrees. Okay, so this topic is nice because they give you all this formula. Okay, The next formula there is the area of the sector. So the area of the sector, they even give you this formula here and that formula there. You see, so those two, you can either use this or that, depending on what is given. On the first one, the S there is, remember, it is the arc length multiplied by the R. If I'm not given the arc length, I'm given the angle, then I'm going to change, I'm going to use the formula R squared multiplied by theta all over 2. So I must check on my question. Am I given the angle or am I given the arc length? So now here you can see they tell you R is always the radius. If I'm given the diameter, I must change it to a radius. S is the arc length. Theta is the central angle in radians. Can you see? Here we're working with radians there. The last formula there will be the where you're calculating the height of the segment, or you're calculating the length of the chord, or the diameter of the circle. So I can either calculate the h, which is the height, calculate the d, which is the diameter, or calculate the length of the chord. So you must be given two things. So it's either given the diameter and the height to calculate the length of the chord, or you are given the height and the chord, length of the chord, and you're calculating the diameter. Alright, now let's check this one on measurement. That question comes every year. Every year. So this we must go and practice and get it right. The question whereby they ask you to calculate the area, there you are having the area of T, the M1 and M2, M3 and that. So here they tell you M1 is nothing else but the first ordinate plus the second ordinate divided by 2. So in other words, M2 will also be the same. The second ordinate plus the third ordinate divided by 2. So you carry on like that. So in this formula, you can see the two formula, they're different there. So now with this one formula, you take the first ordinate and the last one, the last ordinate. Okay, and the first one. Then you add them together, you divide them by 2. That is those are the only ones that you take there, that divide by 2. Then you take the second one, the third one, depending on how many you have. Okay, and the last one here you take the last but one. So let's say I've got my ordinates. My last ordinate is 2 meters. My last ordinate is 2 meters, and that ordinate there is 3.1 meters. So in other words, the ordinate that I'll take there will be the last but one. So this one is the last one, so I'm going to take the last but one. Okay, right, I'll show you when we're doing the examples now. Okay, very important slide here. Now here we are trying to target the marks. You know, we need to target the marks so that then we are able to can say, in my first 1.5 hours, I'm targeting my pass. I'm targeting probably 80 marks. I'm not targeting anything that less than 80 in the paper. So I'm targeting between 80 and 100. So let's see. So I'll say this is paper 1, which you have done last week. Now in paper 2, I've got analytical geometry, which is 25 marks. So if, for instance, I target 20 out of that, at least 20 marks, then I'm getting there. In trigonometry, 12 marks. That's your minimum mark that you must get. If I can be able to target 20 in analytical geometry, 12 in trigonometry, 10 in Euclidean geometry, and 11 in mensuration and circles, angles, and movement, then I'll have 32 marks, 42 marks, 53 marks. So I'll get 53 marks, which is 35%. But this is very low. We need to target more marks here. And in the paper that I've chosen for today, I've targeted about 80 marks. So you'll count with me. Count with me. When we do the activities, please count with me. We have targeted the analytical geometry, we have targeted about 13 marks here. And then in trigonometry, we have targeted about 28 marks. So I'm going to show you how. In Euclidean geometry, I think in Euclidean geometry, we targeted about 18 marks. And there we targeted about 21 marks. Right, out of 35. I'm going to show you how. Okay, how we're going to do that. Which the total there you can see it's 80 marks. Okay, so let's target the 80 marks, which is going to be our minimum. Remember, we need to get 150 out of 150. But the minimum that we must get, at least in 1.5 hours of my writing, I must be able to get targeted 80, so that then I can, then in the next 1.5 hours, I can then target to get more than 80 by doing questions that I did not do in the first 1.5 hours. Now, here's the paper that I've chosen for you. In analytical geometry, activity number 1. Check this. Here's the story. In the diagram below KLM, so I see there's a triangle KLM there. It's got its vertices, so 1, 2, 3, these are called vertices. What? P, they say is a midpoint. Now I've been told that P is a midpoint. Then what do I know? I go to my formula sheet and check. Oh, midpoint, I've got a formula. No problem. If they ask me that question, I'll be able to do it. They say equation of the straight line. I've got the equation of the straight line, but it is not written in the form that our teachers have taught us. What do we do? Change it out. Write it as y equals to mx plus c, meaning that the minus x must go that side. It will be positive x, and then the 6 will remain as plus 6. Right. And they say the angle from there is a beta, so I've got an angle, so I can get that angle by using the formula for the angle inclination. Now they say given the equation of the straight line as this one, you see they are guiding you. Given the equation of the straight line as that, write down the numerical value of the gradient. So the gradient here, remember this is y equals to mx plus c. Oh, I can see you now you're smiling now to say, oh no, the gradient will always be that point, that value there. So now 1 mark only, we must get that 1 mark. We need to write down that the gradient of that thing there will be 1, and that's 1 mark. Okay, because I've already done it like that. I've already written it as y equals to mx plus c, of which the m will be the gradient of that line. Now let's carry on. Now the size of that angle here, already I've got the gradient of that line, isn't it? I've got a gradient of that line. I know the gradient of that line is 1. So what do you know about the angle of inclination? Is the angle that is formed between the x-axis and the straight line. Okay, so here is my x-axis, here is my straight line, here is my angle. Remember an angle, what is an angle? An angle is the space between 2 lines with the same vertex. So that's the amount of space that is formed between 2 lines. Here is the 2 lines with the same vertex. Okay. Now the angle of inclination of LM. How do I get it? I already have the tangent. So what is my formula? Go to my formula sheet. Check. Tan of an angle equals to the gradient. And what is that gradient, by the way? It's 1. Then I use my calculator. The angle, what do I do? Go to my calculator and press shift tan, then I press 1 and I press equals to, the angle that will appear there will be 45 degrees. So I'll get my 2 marks there. Alright, please count with me how many marks we're having now. Right, and these are easy questions that we have picked up there from the question paper. Write down the numerical value of D. I can see there's a D there, so that's why I could not get the formula, the gradient by using the points on the line, because now I must have the value of d for me to get the gradient by using the formula for the gradient. In this case now, because I've got d there, what do? I know I've got a formula y is equals to x plus 6. And that line here, LM, you can see that point is on the line. The easy way to find the value is to first check the equation of the line that is given. So the equation of the line there is x, y equals to x plus 6. And this point here, I must substitute. The value of y is 4. The value of x is d plus 6. So I can just quickly solve for d. That's easy. So my d will be equals to -2. And I must check on my sketch. Can d be -2 there? Yes, I think so. So my d can be -2 here, which is the x value. So I think I'm right because it is on my left hand side. Can you see how you can check that whether your answer is right or wrong? If you return 2, so it meaning that your d will be somewhere there, 2 will be somewhere there. So it cannot be there. Right. Now, calculate the coordinates of P. That's the easy one. Remember they said P is the midpoint of that line, which means my P is going to be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, just 2. Okay, so now how am I going to get that? So I'm going to say 2 plus minus 10, which is going to be 2 minus 10 all over 2. That's for my x value. For my y value, I'm going to get what? 2 minus 4. So it will be 2 minus 4 all over 2. So my x value is going to be 2 minus 10 is minus 8 divided by 2 will be minus 4. My y value is going to be 2 minus 4, which is minus 2 divided by 2 is going to be -1. So my p value here is nothing else but minus 4 and -1. Let me check if it's correct. If this is minus 2 here, that point here can be minus 4. Minus 2, minus 3, minus 4. I'm correct. That point is 0, so that one will be -1. So it is below the x-axis, which is correct. So I can readily say I have the coordinates of P, but I must write it in that form. Okay. All right. Now, easy. Let's go to the next one. These are easy questions. These are easy questions where we must get marks. Write down the gradient of the straight line parallel. See, the keyword there is parallel to line LM. So I need any line that is parallel, whether it's there or there or there, but it must be parallel to this line. What do I know about parallel lines? The gradients of parallel lines, they are equal. So in other words, if I know the gradient of that line, which is 1, therefore the gradient of the parallel line, which is going to be +1. Sorry. Okay, and that's 1 mark. You see. So question that deals with 1 mark, you just need us to write an answer. Okay. Right. It says hence, meaning that let me use that gradient. You see, the word hence means use whatever you got in the previous question, then put it there. So now let's use the gradient. Let's use that. So now let's use the gradient there. But they need what? The equation of the straight line. Remember, I told you about the equation of the straight line. So which means I'll have y equals to mx plus c. But I already have the gradient and a point. You see, they say it passes through what? K. So which means my y value is 2. My gradient is 1. My x value is 2. I don't know what c is. Remember, c will always be calculated. Right. So which means I'll have C 2 minus 2 is 0. Therefore, the equation of my line is going to be x. Y equals to x. Why? Because I don't have a C, because the C will be 0. The gradient I know it's 1, so it will be 1x. So I'll just write it as y equals to x, which means that that line is going to pass here. Let me see, y is equals to x, it passes there, and that line will be parallel to that. Okay, can you see how they've broken down the question? So in other words, they will have asked you to say this question here, they just say determine the equation of the straight line parallel to LM passing through K, without giving you that question. And they will give you 3 marks there. But they decided to say, let's first ask what the gradient is, and then from there let them ask, the other question will be determine the equation of the straight line passing through that point. Can you see how they break down that question to say, at least this learner, if he doesn't understand this, he'll get 1 out of 3, and 1 out of 3 is a pass because it's a 33.3%. Can you see that? Ne? Right, but we don't want that. We want you to do the whole question. In this case, they're just giving you confidence to do that question. The next one, this question, I have a problem with this question, learners, because you don't get it and it comes every year and it comes in the same fashion. And you see it every now and then in question papers since the beginning of this year. You see that that question, and you're still getting it wrong. Please, 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 everyone, pay attention now. With this question, what it means? It means it's an ellipse. In other words, it is not a circle. And the diagram, the diagrams that we see at the end of the year, they are amazing. We don't want to see those anymore. There, you cannot draw a parabola graph. You cannot draw any other thing. You cannot draw a circle. You must draw an ellipse. Now, I'm going to show you how. Now, here they say x squared over 5 squared. You see, this is a squared, meaning that your a is already given. This one is your b. So, the b is already given because the square is already there. That side is always going to be equals to 1. So, I go to my sketch there and I check. 5 squared. 5 is on the x-axis. So I go to my x-axis and I locate a 5. On the left hand side, I locate a minus 5. See? Then I go to my y-axis. Then I locate 3,5 somewhere there. And I allocate 3,5 somewhere there. Right. From there, what do? I connect this by using a freehand. I like doing this. Then from there, I can then complete this, and then I just do that with my freehand, and I've got my nice, and I write down 3,5, negative 3,5. I write down 5 and negative 5, and I'm done. And this is an easy 3 marks that everyone must get at the end of the year. So if that is given here and you find that it's x squared over 25 plus maybe y squared over let's say 17, it's equals to 1. So which means I'm going to get the square root of 17, the square root of 25, and then I put my points there. So if the squares are not there, you must do a square root. Remember, the a is squared, the b is squared. But on the Cartesian plane, we can put values as squared. So we must get the square roots of those numbers. Alright. Okay. That is the end of our analytical geometry. And when I counted all those marks out of analytical geometry, sorry, this is 25, it's not 35. When I counted all these marks there, out of 25, I got 13. At least if I can get the minimum of 13 in this analytical geometry, I'm on the right track. Right. Getting down to the next topic, the trigonometry. In the first question, trigonometry, remember now we go to the formula that deals with trigonometry. In the first question in the trigonometry of this paper, they asked you to determine the value of. They did not say without using a calculator or that. Those are easy questions. I must use a calculator. And this question in calculator usage comes every paper. I must get it right. So what do I do there? I just substitute the value of B there by 59. Go to my calculator, press sign, press 59, press equals to. And then the answer that I'm going to be getting there is 0.86. And you must write it correct to 2 decimal places if you are not told to write it in any other form. You must write it 2 decimal places, and the information, the instruction is there on the first page, instructions and information. So you must go and read those, correct to 2 decimal places. Let's get to the next one. The next one, I'm going to substitute my A now. It's 66 degrees plus cos of 59 degrees. My problem now is that I don't have sec on my calculator. But I know that sec is 1 over cos. So now I must write it as 1 over cos. Then I can go to my calculator and do that. 1 divided by cos of 66 and then plus cos of 59, and the answer that you're going to get there, I hope you're getting the same answer as I got. It's 2.97. It is not in degrees, it is just a number. Don't put a degree sign on that answer. Okay, nice question. And it's 3 marks. You see there it's 1 mark because you're just punching sign of 59. This one is 2 marks because you are substituting. You are changing this one, you are changing that sec to 1 over cos. Then you are getting your final answer. You see, calculator usage, you'll get a mark. So you must keep the calculator that you've been using to practice, and then you must use it in your exam papers. Okay, don't change it. Right, I still feel that this question here must be done. Everyone must be able to do this question. When we start with our trigonometry in grade 10, this question is a grade 10 question. So which means, then I drawing a sketch. You see, they say with the aid of a diagram. So I am drawing a sketch and I'm not using a calculator, which means after I've drawn my sketch, I'm going to draw it here. I'm going to draw my sketch. Then I'm going to draw it in the 4th quadrant. I'm going to explain quickly why. The tangent is negative, and the quadrants that I'm working at, it's from 180 degrees to 360 degrees. So these quadrants are out. I know tan here it's positive, and here it's negative. So in the 2 quadrants, the tan is negative in the 4th quadrant. See how I draw my sketch. Then I know tan is y over x. So my y value is -2. My x value is a 3. Then I need the r value. So I need my r value. How do I get it? Pythagoras. Okay. So my angle that I'm working with is an angle alpha. So now I'm going to say r squared will be equals to 3 squared plus -2 squared, of which I'll get 9 plus 4, which is 13. So r squared is 13, but I need the value of r, which is square root of 13. So I'll have this. Okay, so now I now have the value of r. I now have the value of x, I now have the value of y. So now, for me to do this, it will be now easy. Can you see where the 5 marks comes from? So already I have my sketch, it's complete. And they said no calculator usage. So I'm not going to use any calculator. I'm not going to say the square root of 13 is 3 comma something. No. So I'm only going to use these values that are the x, y, and r. So I know cot, it's an opposite of what? Tan. Then I'm going to say 4 into. If tan is minus 2 over 3, means that cot is 3 over negative 2. So I'm going to write 3 over negative 2. Right? For sine, I'm going to my sketch. The sine of the angle here is opposite over hypotenuse. So my opposite side is negative 2. My hypotenuse is square root of 13, and I square it. From here, I can use a calculator. Okay, so I can take this into the calculator. You see, in this case, I can either do it manually or I can use the calculator. So if I want to do it manually, I can do it manually, but I can put it on the calculator. We'll still get the same answer, and no one will tell if you have used the calculator. But if you give it to us as decimals, then we know you have used the calculator. So please leave it as a fraction. Right. So now I'm going to get minus 6. Then I'm going to get, if I multiply this, I'm going to get a 4 over 13. If I multiply that out, I'm going to get negative 74 over 13. And I leave my answer like that. Once I say 13 into 74, and I get this a decimal, you'll get a 0 because the question says without. Okay, so if I leave it as a decimal, it's fine. I don't need to do this step. I can go from here, I can go directly here using my calculator. All right. Okay. The activity 3 deals with the cosec of x. So now what are we doing? We are solving. That question also comes every year. So all these questions that I'm doing here comes every year. So I'm going to try to take 2 minutes break so that you look at this question and then you try to do it, and then from there we'll come back after 2 minutes. Right, welcome back, and I hope you and trust you've done that question. Now let's look at that question. The cosec of x, we know cosec, we change it to what? To 1 over sine of x. So which is the same as negative 3,054. But I want to write down sine on its own. So I'll have the sine of x is equals to. So which means that it will be 1 over 3,054 with a negative sign also. So if I use my calculator, x will be equals to. So my x will be equals to, it's my reference angle, remember? So my reference angle in this case will be 19,11 degrees. So you go to calculator and say shift sine, open bracket, negative 1 over 3,054. Then there's the angle that we're going to get there. So we're going to get 19,11. But now remember, this thing here is negative. Where is the sign negative? Where is the sign of cosec negative? It will be in the third quadrant and the fourth quadrant, which means now that this is my reference angle. So my answer will be x is equals to 180 degrees plus the reference angle, or x will be equals to 360 degrees. Remember, now we're talking the reduction formula. So in the third quadrant is 180 degrees plus, in the fourth quadrant is 360 degrees minus. So this is the third quadrant, this is the fourth quadrant. Sign is positive here, sign is positive there, it's positive there, but it's negative there and there. So remember, we're talking about sign now. So now it's 360 minus 19,11 degrees. So my x value will be equals to 340,89 degrees. The other x, if I add these two, I'll get 199,11 degrees. So there's your 5 marks, where you have 1 mark there, 1 mark there, and then from there you're going to have your mark for this reduction formula, and the 2 marks will go into the final answers. Okay, right. So please make sure, why didn't I put a negative angle here? It is because when we're looking for the sign for the reference angle, we use a positive value there. So we're going to say shift sign 1 over 3,054. Don't put the negative so that you get 19,11. Okay, right, because if you put a negative, then you're going to get a negative angle, and then from there, when you add it, you get wrong answers into it. Okay, right. This question also, this question, it's an easy question. These are 3 easy marks. Look at this. I already said to you there, remember, I said that thing there is the same as 360 degrees when I was explaining the angles there. So now, 2 pi is 360 degrees. So what is the cos of 360 minus? Remember, this is what I've done, 360 minus. The cos there is positive according to our cos diagram. So the cos is positive there. So which means that I must write what? Cos of B. It's not beta, it's B. Cos of B. So my answer is nothing else but cos of B. Right. 1 minus cos squared P. So if, for instance, if I see this cos squared of an angle, remember I have the cos squared, the sine squared of an angle. My answer was equals to 1. But if I take this one to that side, can you see how they trick you there? And this is in the formula sheet, right? If I take this one that side, so I'll have I'll have sine squared of P, it's equals to 1 minus cos squared of P. Can you see how they trick you? So which means 1 minus cos squared is the same as sine squared of an angle. So the answer there was supposed to be sine squared of p, and that's 1 mark. And it's from the formula sheet. So you go to your formula sheet, you check this, you get it. Tangent is nothing else but the sine of beta over the cos of beta. I also accept 1 over cot of beta because I know tan and cot are friends. So in other words, the other one, tan will be 1 over cot, the cot will be 1 over tan. So I can accept this one, and I can also accept this one. All right. Now, the next question here, everybody must also get this one right. It's always there in your question paper. If you have already done 5 question paper, you'll see that there's a similar type of question in all the question papers. Now let's look at this. We said pi is 180, no problem. 2 pi is 360. Okay, pi over 2 is 90. So now 180 plus. Now if we go back again and do our cast. Right. This is the first quadrant, second quadrant, third and fourth. So 180 plus. So if I go to 180 plus, this is 180 minus. That is 360 minus, and that's a angle in the first quadrant. So what I'll see here is 180 plus falls in here. There's a t, there's no s. So meaning that this one will be negative. So I'll have negative 2 sine of b. Right, put it in bracket. That one we have already done it in the last slide, so we got the cos of b. I'm not going to give you a mark for that because we've already given a mark for that. The tangent of 180 minus, so 180 minus falls in this quadrant, there's no t, so if there's no t, I'm going to put a negative term of b plus cos 180 minus, there's no c there, so I'm going to put a negative, multiply that. So now 2 over sec is nothing else but cos. So in other words, 180 plus, there's no cos here, so therefore it will be negative sec of b. So I'm going to give you a mark for this, mark for that, mark for that. So already you have got 4 out of 6. 1, 2, 3, 4 out of 6. Obviously that one will have the 5th mark there. Now I'm going to negative, and negative will give me a positive. So which means I'm going to have 2 sine equals sine equals sine there. 2 sine of b times cos of b. Tangent changes to what? Sine of b over cos of b. You already got a mark from there. The negative and the negative will give me a positive times a positive is a positive. Then I'll have the cos of b, but I know that this thing here is 1 over cos over 2. So it's 2 over this. So if I multiply this 2, I'm going to get 2 cos of b. Right. Now I can see that guy cancels out with that guy. I'm left with 2 sine b times 2 sine b. I get 2 sine squared of b. There's a plus sign there. Cos of b times cos of b will give me 2 cos squared of b. Oh, now I can see that there's something here. Common factor, it's 2. I'm left with sine squared of b plus cos squared of b, which I already know is my famous one. So there's the famous one in our mathematics, and that answer will be 2. So can you see the whole thing there that was given there is nothing else but 2. Okay, I didn't substitute anything. I substituted the pi with 180 degrees, but I did not substitute the value of b. I don't have decimals, so I don't have anything. So that answer is exactly equals to 2. Right. Okay. Now, let's go to activity, the last activity, which is a function, and that function everyone must get because we are having a calculator. Okay, 6 marks that everyone must get also. They say, sketch that graph. Take out your calculator, put it next to you, and then from the calculate per point, you can calculate per point. Okay, if I see they've given me a ton, I know ton works with 45, so already my graph was supposed to be having 45 there, 45 there. It was supposed to have 135 somewhere here. Okay, right. Immediately I see a ton here. Then I go to my 90 and I draw an asymptote. At 270, or the graph will stop at 180, so I don't need another asymptote. Okay, right, good. So now, let's look at this. I now want to substitute. If I don't want to draw the graph, I know how to draw this graph quick, but I want to substitute. If I substitute the value of x by 0, then if I substitute by 0, I'm going to get a 1, because sine of 0 is 0, plus 1 is 1. So at 0, it will be 1. Right. If I substitute the value of x by 90, I'll get sine of 90 is 1. 1 plus this 1 will give me a 2. So at 90, it will be 2. If I substitute by 180, sine of 180 is 0. Plus 1 is going to be 1. So it will be there. So in other words, if I want to draw my graph, then my graph must stop at 180. So I'm going to draw my graph, and I'm going to do this. It stops there. So I'm going to have that graph, and it stops there. And I'm done. And that's my graph of f. And that's my 3 marks. Then I substitute. I know tan works with 45 and 90. So if I say tan of 45, tan of 0. Tan of 0 will be 0. Tan of 45 times negative. Tan of 45 is 1. Times negative 1 will be negative 1. So at 45 it will be negative 1. Okay. Tan of 90 is undefined. So here that line will come closer to this. So I'm going to draw my sketch. So I'm going to go this way, and I'm going to go that. So I'm going to have that. Remember, my tan graph will always have an arrow, but this graph, it stops there. It doesn't have an arrow. Again, I'm going to say tan of 45 of 135. It's going to be negative 1 times negative times this negative gives me a positive. At 35, it will be 1. Tan of 180 is going to be a 0. So I'm going to come here. So meaning that my graph is starting this way, coming to that. It stops there, but there's an arrow there. Okay, right. Meaning that the graph is still going up, 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 but it doesn't touch this line. So I can name this graph here my graph of G, and the 6 marks is there. Simple. So you use a calculator, do it per point, and then you're going to plot those points as you do them. Okay. All right. So that's a Mahala 6 marks. This one. Everybody must get this 6 marks. Okay. So our trigonometry, when I check that marks, the marks in the trigonometry only on those questions that we have done is 28 marks. Remember, we've got the 6 marks and the 6 marks, and also the 5 marks that we have done, the 3 marks, the simple 3 marks that we have done, and we also had the other 5 marks. So that will be 28 marks. So you see, in trigonometry, if you can go through those questions that we have done, you can get up to 28 marks. Okay. Now let's get to the Euclidean geometry, which is 40 marks, but we are targeting some marks here. So remember, we are targeting marks in the question. So I've taken a question paper and say, with my learners, all these learners must get a minimum of 80 and a maximum of 150. But I've just targeted these questions to say each and every learner in the province must always be able to get 80 marks in paper 2, which is minimum. Then from there you can move on to get the maximum mark, which is 150. Look at this one. These are the theorems. You must know the wordings of those theorems. So in other words, you must know the keywords in each and every theorem. 9 theorems in grade 11 and 2 theorems in grade 12. So you must know those things, and you must know the wording and the keywords. So you just go there to a theorem, wording of the theorem, underline the keywords, because that's where we ask the questions. See, there is a keyword that we have removed today. So it says the line drawn from the center of the circle perpendicular to the chord. It will be the keyword that we have underlined to the chord, and the other keyword here will be bisect the chord. You see? So those are the 2 keywords in theorem number 1. Perpendicular, bisect. Alright. Now, the next one is here. We have removed the keyword here. So we say the tangent to a circle. In other words, I have a circle and I have a tangent to a circle. And they talk about the radius. So the radius at the point of contact, what does it do? It creates 90 degrees. So the wording that we have removed, the word that we have removed there, it's perpendicular. So if you check here, this word is already there. The answer was already there in the question paper, but you did not see it. Okay, right. Now, next one. Activity 2. I love this activity, these riders, because they're quite so easy. Right, let's check this one. They say in the diagram, O is the center of the circle BCD. So BCD, the points there, BCD are on the circle. Chord BD is produced to meet CF at F such that F is 27 degrees. That angle is given. But there's something very interesting here. They say O1, it's 4 times angle F, which is given. And they say write down O1, the numerical value of O1. So easy. So what are we supposed to do? O1 is equals to 4 multiplied by what? Because F is 27, so I must get that as 27, and my answer was very easy. So I think my answer was 108 degrees. Alright. Remember, we must also give the reason. But the reason there will be given, because we are given that O1 is 4 times F. Very important that you understand the given information. You must know the reasons. They are there in the exam guideline. So if you haven't received it, please ask it from your teachers. The exam guideline has got all the acceptable reasons. I think it's the last 5 pages, last 4 pages. Right. Now, let's get to the next one. Same question. Now they're asking us to calculate. Now we already know that O1 is how much? It's 108 degrees. Now they ask us to calculate D1. See. Now D1, it's angle at center, it's twice angle at the circumference. So meaning that the angle D1 there is half of this. So D1 is going to be half of O1. Alright. So that gives us now half of, now what is O1? It's 108 degrees. Meaning that D1 will be 54 degrees. But they want us to give us a reason. Already, if I give them that, I've got 1 mark. Then the other mark is for the reason. So I'll get, so 1 out of 2 is 50%. So in other words, if I don't know, if I struggle with the reason, I'll then have 50 marks, 50% of that question, 1 out of 2. So, but now let's learn to get the reasons. Let's learn to write down the correct reasons there. So what will be the correct reason there? It will be angle at center equals to twice angle at circumference. Okay, so that is my reason there. That's my reason. Okay, so there is a mark for the reason. The next one, it says, hence prove that DC is equals to DF DC equals to DF. I must prove that. But how am I going to prove it? How am I going to prove that this line equals to that? So I know that if that line equals to that, then it forms an isosceles triangle. What do I know about isosceles triangle? These angles here will be equal. See? Those angles will be equal. But I must first prove that this angle is 27. Then I can then say these lines are equal. Now, how do I prove that that angle is 27? It's 27. So I know that C2 is equals to D1. And they're all equals to 27 degrees. So C2, so if you look at C2 and D1, those angles, C2 and D1 will be equals to 27 because exterior angle of a triangle. Now let's look at this one, because that angle here is 54 degrees. And it's an exterior angle of a triangle. Which means that if this one is 27, that angle here will also be 27. Okay, so not D1, sorry. So that angle here will be equals to F1, sorry. Right, so 27 plus 27 will give me 54 because that's exterior angle of a triangle. So the exterior angle of a triangle will be equals to the two angles that are inside the triangle and they're opposite. So the reason they will be exterior angle of a triangle. Right. So you see that that one is 54, that one is 27. So these two angles must give me 54. Which means that the angle here will be 27, so that will be there. So now how do I then prove that? Then I'll say DC is equals to DF, and I must give a reason for that. Now what will be my reason? It will be side opposite equal angles. That's very important. You must know the two theorems, the two reasons. The other reason will be angles opposite equal sides. That's when I'm proving the angles. If I'm proving the sides, it will be sides opposite equal angles. So that angle there will be 27, and therefore we can do it. The other way to do that will be to get to this angle here. I can get D2. After getting D2, then I can get sum of angles in a triangle. So 54, I can get that angle here, which is going to be 126. Then I can be able to get the other angle to be 27. Okay. All right. And there's 3 marks. So the 3 marks there, the mark will be for that, and the mark will be for this one and the reason. So here the two reasons will give, we'll have 2 marks, and the answer there will give you 1 mark. Okay. Right. Activity number 3. Nice question here also. Immediately, how do I see? I'm seeing a tangent. What else do I see? I'm seeing parallel lines. Already, I know that this angle here will be equal to that angle. Oh, alternating angle. Okay. Now, but let's look at the questions. O is the center, so I've got a center. Already I've got radii, so these lines here are going to be equal. I've got radii. So as I read the question, I must then go to my sketch and then try to make sense out of the sketch. C4 is 55 is given. C2 is 38 is given. CD is parallel to FH. I've already indicated that. Now, state with reasons what will be D1. So D1 will be equals to 55 degrees. What is the reason? The tangent and the chord theorem. Tan-chord theorem. Gonna see. So now means that D1 will be equals to 55 degrees. The reason will be tan-chord theorem. So you must write it like this. Okay, so it's 1 mark for the 55, 1 mark for the reason. F3, let's go to F3 now. F3 already, can you see? I know this one is 55. F3 is that angle there, so that one will also be 55. So no problem here, this is 55, but now the reason is now different. So it will be alternating angles. Very important, I must write down the lines that are parallel. So if you leave out this part, you are not going to get that mark. So you must write down lines that are parallel, so that then we know that you are talking about these lines that are parallel. Okay, right. We already know that this one is 55. We already know that this one is 55. So now we need F1. So we need that angle F1 here. So how am I going to get F1? So F1, first I must get C3. So I can get C3 because I already know that that angle here forms how much? 90 degrees. So which means that if I've got 55, that angle there will be 35. So if I know C3, so first I must get C3 equals to 55 degrees, right? And then if that is 55 degrees, which means that F1 will now be equals to, that is 35 degrees. Then this one will also be 35 degrees. What is the reason? Remember I said these are D, so it forms a isosceles triangle. In the isosceles triangle, what do we say now here? We are now going to say, see the reason, angles opposite equal side. What is given becomes the last part. So I know this one is given as D. Then the one that I need, I've proved now, it's on my left hand side. So if you look at the previous one, it was sides opposite equal angles. I was proving the angles, the sides were given. Okay, right. Now DFC, let's check DFC. DFC. So meaning that I'm looking for this angle, but I already know this one is 35. So I'm looking for the whole angle here. You see. So for me to get this angle, I need to get that angle F2. But that will be difficult for me to get that angle. So now what do? I look for this triangle here. Can you see that triangle here? I look for this triangle. In this triangle here, I'm looking for the whole angle here, remember. So now, if I look at this triangle, how many angles are given? This angle is given, that angle is given, this is missing. So I'm going to say DFC will be the same as 180 degrees minus this one, minus the 38, and minus the 35 degrees. So what is left? So what will be my reason here? So it will be interior angles of a triangle. Okay, right. So if I calculate this, if I subtract that, what am I left with? 52 degrees, meaning that DFC will be 52 degrees. Okay, so the whole angle is 52 degrees. If they wanted me to get F2, I'll just subtract 35 from 52. Then I'll get that angle. But that will be a challenging one. Okay, right. Okay, so in Euclidean geometry, all these questions that I've done now, they can give you up to 18 marks out of 40. Okay, that's your minimum mark. Remember, you still have other questions there, but this is the minimum mark. Okay, the last topic that I'm going to look at now, it is the circles, angles, and angular movement, which is 25 marks. But the 25 marks, remember, it's only for circles, angles, and angular movement. And the 10 marks, that makes it a 35, will be on measurement. Okay, so the 25 marks will be here. So the 10 marks will be on the other side. So write down the conversion factor. So that conversion factor is already there in the formula sheet. So in other words, how do I convert this? So from degrees to radians. So from degrees to radians, I multiply by pi over 180 degrees. Or I can multiply by a decimal of 1,7. So those two answers are acceptable. Because I know you love your calculators. You'll go there and say pi divided by 180 and then the calculator gives you 0,17. Just write that answer as it is. Okay? Right. How do I convert 222 degrees to radians? So simple thing. Write 222 multiply by pi over 180 degrees, and then you punch it on a calculator, and the calculator thing will give you 3,87 radians. Remember, these are radians. Okay, right. I've changed them from degrees to radians by multiplying by that. If you want to change them from radians to degrees, it's 180 degrees over pi. So you just switch over this one. Okay, right. Here's a nice question also here. Calculate the rotational frequency of the rear wheel in revolutions per second. You are now given this one as your circumferential velocity. So I go to my formula and check. My circumferential velocity is v equals to pi dn. Alright, that's my formula. But now I can, when I check this, I've got this one in millimeters. So I must change it to meters. Remember, I need everything in meters and the time in seconds. So I'm going to change this in millimeters. So I need to divide that by 1,000, of which I'll get 0,65. All right. Now I've got 45 kilometers per hour. I need it in meters per second. So which means that kilometers to meters I must multiply it by 1,000. Because I want to change this kilometers into meters, so I must multiply by 1,000. Know your conversions. Now from grade 10, I want to change per hour, and then I want to make it per second, meaning that I must divide this by 3,600. So that's what I'm going to be doing there. Okay, so the answer that I'm going to get 12,5 meters per second, which is my V, you see. So my V now is going to be 12,5. Pi is there. Remember, this one is a radius, so but I need what? I need a diameter. So my diameter will be 0,65 times 2, which is 1,3 meters. So in other words, my diameter is 1,3. What do I looking for? I'm looking for rotational frequency. So which means my n is going to be 12,5 divided by pi times 1.3, and the answer that I'm going to be getting there is 3,06. This answer will be in revs per second. Right? So my answer there will be nothing else but 3,06 revs per second. Right. The next question is very clear also. Determine the angular velocity. So the angular velocity formula, you go to your formula sheet, is the omega, which is pi, 2 pi n. But already, what do I have? I have the n from the last slide. Then I'm going to now calculate that. That's an easier question. 1 mark for the formula, 1 mark for the substitution. Do it on a calculator. Then what do we get there? We get 19,23 radians. Remember, this is radians per second. Okay, easy question there. So you go to your formula and check this weight, then come up with the formula sheet. Right, now next one, same thing there. You look at, for the keyword, you need a height of BR. The height of BR. What do I know? I need the height. This is the radius. So my diameter is going to be how much? 30. Right? So I have this. So AC, the whole of AC there, it's 18. Right? The whole of AC there, it's 18. So it's a chord. So now I already have a formula. 4h squared minus 4dh plus x squared equals to 0. Then the h I don't have, so I'll have 4h squared. The diameter I have is 30. The height I don't have. X squared I have is 18 squared equals to 0. Then I'm going to write it properly there. Then I'm going to get 120h plus 324 equals to 0. Then I use a quadratic formula. So if I use my quadratic formula, that I think you can do there to use the quadratic formula. Remember, I'm looking for h. So if I use my quadratic formula there, this you can do on your own, and then you are going to get the answer to be 27, or h will be equals to 3. If you're strong enough with your factorization using the brackets, you can be able to do that. Right, but if you're not, please don't take chances, use a quadratic formula. But we know that h cannot be 27, br cannot be 27 there. That line is too short to be 27. So that line here will be the other height will be 27, and that other height will be 3. So in other words, I'll take the one which says h equals to 3. That one will not be correct. So that's 3 centimeters. The last but one question. Right. That question that I was talking about. First of all, look at this. It's 0.4 meters, but they need the length of one equal part. So which means if 0.4 is for 2, you just divide that by 2, you get 0.2 meters. That's the one mark that they're talking about. Okay. Right. These are the ordinates that has been given to us. So in the next question, that's the one that I was talking about. That in the first formula, I'm going to use the second formula, which is quite easy for me. In the second formula, it says you take the first and the last, then this one will be in the middle. Okay. So what do? The formula is a, my a is already 0.2. My formula will be, the first one is 2 plus 1.42. So I've taken the first and the last. I add them together, divide them by 2. Then I'm going to add the 1.7. The 1.7. I'm going to add the 1.59. I'm now going to add the 1.48. I cannot add this one because I've already added it there. So all the numbers are there. So from there, I just take my calculator, and the answer there, that will be 1.6 square meters. Remember, this is an area, so it's 1.6 square meters. And the 3 marks there, it's for writing this, writing the formula, and writing the substitution and the final answer. So the 3 marks is already there. Okay. If you use the second formula, it will be, you'll get the same answer. Remember, in the second formula, you take this 2, you divide by 2, this 2 divide by 2, this 2 divide by 2, and that 2 divide by 2. Okay, and then you have your answer. That one will be 0.2. The last question here is a measurement question, which is mensuration. So here, the formula, you'll get them in the question. The formula are always there in the question. So, surface, you must read the question, the formula. Surface area of a sphere is this. You must read those questions. The volume of a sphere is this. Look at what the question wants. It says, calculate the exterior surface area of the open hemisphere, which means that they need you to do something on that formula to calculate. So in other words, a sphere, a hemisphere is half of a sphere. So which means that the formula must be divided by 2. So the formula that I'm going to be writing here for the surface area of that sphere will be half of the full sphere. Okay, which is going to be, because that's the exterior part, you cannot calculate that part there. So which means it will be half. So half of that will be 2 pi r squared. So I just substitute the value of r. I look there, the radius is given as how much? 30. I substitute by 30, then I multiply out. My answer becomes 1000. Remember, this is squared, 1800 pi. Or if I use my calculator, it's going to be 5654,87. Remember, it's meters squared or centimeters squared because it's that area. Okay, so these are questions that we must get. We must not be afraid of these questions. We must always try and look at this question and make sure that we read that question with understanding, and then try to do that question. Those are easy questions. If they wanted the volume of that, what will I do? It will be half of that. The volume of the hemisphere will be half of that. So I can be able to get it. Okay? Right. Look at the conversions. You must always know how to do the conversions. That's very, very important. Okay. So with paper 2, these are the questions, and all these questions that I've done here, they can give you up to 80 marks out of 150, and that is a good mark for a start. Remember, then we move to getting 100 and 120 and 130 up to 150 degrees, 150 marks. Okay, so that is the end of my presentation. Good luck with your examinations, your writing next week, and thank you so much.